Minute Math. When you need help, you use Minute Math.
I'm Sean Gannon, and this is Minute Math. Today we're going to learn about higher order derivatives. And for each problem, we're going to find the indicated derivative with respect to x. So if I was given this problem, y equals a negative x squared, and we want to find the 2y dx squared. All right, the second derivative right there. Well, first thing we need to do is find the first derivative. So I want to find dy dx here. Okay, I'm going to use the power rule, bring down that 2, so we now have a negative 2x, right, to the first power, essentially, right? So our first derivative, using the power rule, 2 comes down, right, and then we subtract that exponent by 1, giving it 2 minus 1 being 1. Now, I have to find the second derivative there, so I got to find what we got there, the 2y over dx squared, and that's equal, well, the 1 comes down, right, so we have negative 2 times that 1 times x to the 0 power. Well, x to the 0 power is just 1, right, and negative 2 times 1 is negative 2, and so our final answer is d squared y over dx squared is equal to a negative 2. So our second derivative here is just negative 2. F of x is equal to 4x to the third power, and we want to find f double prime, okay, the second derivative, okay? Well, first we need to find the first derivative. So when we find the first derivative, f prime of x, okay, we're going to use the power rule. The 3 comes down, 3 times the 4x to our exponent, which is 3 minus 1. We subtract 1 from the exponent using the power rule, and that gives us a 2, okay? So we have 3 times 4x squared. Now from there, I can simplify that. So f prime of x is equal to 3 times 4, which is 12, right? X squared. But they asked us here now to find f double prime. So I need to find the second derivative now. So that's going to occur right here, second derivative of x. And again, I'm using the power rule again. The 2 comes down out front, times 12x exponent gets subtracted by 1. So it's 2 minus 1 is 1. So now multiply this out, simplify. 2 times 12 is 24. So f double prime of x is equal to 24x. And we don't really write the first power for it because that's just it's not the proper way of doing it. We just know since there's 1x, just x to the first power. And there is our final answer. The second derivative of x, or f of x, is 24x. Y equals a negative 4x. And we wanted to find d to the third power y over dx to the third power. So the third derivative, okay? Well, first thing I want to do is find my first derivative, right? So for my given function. So we have dy dx is equal to, well, I use my power rule, right? So there's a 1 up there. 1 comes down, so we have 1 times a negative 4 x to the 0 power, okay? Well, let's go simplify that. X to the 0 power is just 1, right? X to the 0 power is 1. So we have dy dx is equal to 1 times negative 4 times 1, which is just negative 4. And so that is our first derivative. Second derivative now, so d2y over dx squared. Well, negative 4 is just a constant. It's just a constant there. And so the derivative of a constant is just 0. Okay? So now, by the second derivative, we have a derivative that is equal to 0. Okay? Second derivative. But I need to find the third derivative, and this is where it really doesn't matter how many derivatives you take. Every single derivative from here on out is just going to equal 0 because derivative of a constant, which is 0, right? 0 is a constant, is just 0. And there we have it. Our final answer. The third derivative of y is 0. F of x is equal to 5x to the fourth power. And we want to find f triple prime, okay, the third derivative of f. Well, my first step here is I need to take the first derivative. So we have f prime of x, taking the first derivative. Power rule says the 4 comes out up front, times the 5x to the, subtract the exponent by 1, third power, okay? 4 times 5 is 20, so f prime of x is 20x to the third. I now need to take the derivative again, find f to the second power, f double prime, right? And so I'm going to use the power rule a second time here. 3 comes out up front, 3 times 20, x to the second power, and 3 times 20 is 60. So we have f double prime of x is equal to 60x squared. We subtract the exponent by 1. Lastly, we have one more derivative to do. We have f triple prime of x, okay? 2 comes down, we're going to the power rule again, 2 times 60, and just leave it as x, going right to the first power. Hopefully you can do that now. So it's just 2 times 60x, and f triple prime of x, we can write that, 2 times 60 is 120. And so our answer is f triple prime of x is equal to 120x. Y equals negative 5x to the fourth. And we want to find d to the fourth power y over dx to the fourth. So the fourth derivative here, okay? Well, to get to the fourth derivative, I need to find the first derivative. So dy dx, we use the power rule. Okay, 4 comes out, 4 times 5 is 20, right? So we have a negative 20 here, x to the, subtract, the exponent, 4 minus 1 is 3, so if our first derivative is negative 20, x to the third power. Again, that 4 times 5 gave me that negative 20. So that's first derivative. Now I need to find the second derivative. So d squared y over dx squared. Again, I have to use the power rule. 3 times 20 is 60, so we have a negative 60 right there because it's negative 20. X squared, and we subtract the exponent by 1. So our second derivative here is a negative 60x squared. I need to find the third derivative to get to the fourth, right? So the third derivative, d3y over dx to the third. 2 times 60 is 120, right? So we have a negative 120 right there. Don't forget the negative. X to the first power, just leave it as x, so we subtract the exponent. So we do the power rule a third time. But we have to do the power rule not 3 times, not 5 times, don't go too far to 5, but just 4 times. So we have the fourth derivative here, d to the fourth power y over dx to the fourth. That, using the power rule, the 1 comes down and is just negative 120 right there, okay? And the x ends up being eliminated out because x is 0 power, which is just 1. And here we have our final answer. The fourth derivative of our y function is a negative 120. Y equals 3x to the fifth power minus 2x. And we wanted to find the third derivative, to the third power y, dx to the third. Okay. Well, first thing I need to do is find the first derivative. So we have dy dx here. We use the power rule in this first part. 5 times 3 gave me that 15x to the fourth power. Subtract the exponent by 1 minus here. And the derivative of just 2x is just a 2. Okay? So right now we have our first derivative done, but we have 2 more to go. Okay? But the x did get eliminated. The exponent from x to the first power 1 came down. X is 0. X is 0 is just 1. 2 times 1 is 2. So we find the second derivative here. So d to the second power of y over dx squared is equal to, well, 15 times 4 is 60. So we have 60 x to the third power. And then the derivative of 2 is just 0. So if you want, you can write the minus 0 there. Usually you just get rid of it, but I'll put it there for this problem here. But the next step will just be gone. So now we have d to the second power y over dx squared is equal to 60x to the third power. And that's our second derivative, but we need to find the third derivative. So we go to d to the third power y over dx to the third. Okay? And 60 times 3 is 180. So we have 180 x squared, and that is our final answer. That is our third derivative. The 0, it's basically gone, don't worry about it. And so our third derivative here is equal to 180x squared. Y equals negative 2x to the third power minus 4x to the negative 3 power. And we wanted to find the third derivative. Well, first thing I need to do is find the first derivative. So to do that, I apply the power rule, dy dx here. Power rule, 3 comes down. 3 times negative 2 is a negative 6x squared. Then we have a minus here. Minus negative 3 times 4 is a negative 12. X, we subtract the exponent by 1. So negative 3 minus 1 is a negative 4. Okay, keep that in mind. It's still going to that negative. Now, subtracting a negative is the same thing as adding a positive. Okay, so now we plus a positive 12x to the negative 4th power. Okay, well, let's go find the second derivative here. Okay, so we need to find the second derivative. Let's keep going. So d squared y, over dx squared is equal to, 2 comes down, 2 times negative 6 is negative 12, x to the first power, plus, well, it's negative 4 times 12, and that's a negative 48. That's x to the negative 5th power, right? So the negative came down, negative 4 times 12 is a negative 48, okay? And then we subtract the exponent by 1 to get a negative 5. So now we need to find the third derivative here, the third derivative, d to the third power y over dx to the third. Power rule again leaves us just, well, up with a negative 12 right there. Instead of negative 12x, we take a derivative of that. It's just negative 12. Plus, okay, negative 5 times negative 48. Now, I don't know that off the top of my head, so, okay, we do 48 times 5. Okay, and they're both going to be a negative multiply, so it's going to be positive. 5 times 8 is 40. 4. 4 times 5 is 20, plus 4 is 24, so we have 240 here. So we have a 240 x to the negative 6th power. Okay. Now, when we write our final answer here, we don't like to have x or the power to be negative. So when I rewrite this to the third power y, dx to the third, all right, negative 12 plus 240 over x to the positive 6th power. Okay. And there we have it. We have x to the positive 6th power at the end there. So our final answer is the third derivative is equal to negative 12 plus 240 over x to the positive 6th power. Y equals negative x squared plus 2 to the, times the 5th root of x squared. And we're going to find the third derivative to the third power y over d x to the third power. Okay. Well, first thing I'm going to do actually is, I don't like seeing roots and exponents. I'm going to make this into just a fractional exponent, and hopefully you know how to do that. So we have y equals negative x squared plus 2 times this x squared, and then the 5th root of that is the same thing as 2 fifths, right? Because the 5th root is the same as the 1/5 power, and then x squared is just squared, so if we combine them together, we have x to the 2/5 power right there. So now I can take the first derivative. When I take the first derivative, I have dy dx. Using the power rule, 2 comes out in front, so we have negative 2x to the first power plus, well, 2 times 2/5, or 1, right, times x, and we subtract the exponent by 1. When we subtract the exponent by 1 whole unit, right, that's a negative 3/5, right? We're subtracting 2/5 by 1 is negative 3/5. So to simplify that, we have dy dx is equal to negative 2x plus 2 times 2 is 4, so we have a 4/5 here, x to the negative 3/5 power. Okay? But now I need to find the second derivative. So I have d squared y over dx squared. Using the power rule again, well, that's just a negative 2 right there, plus, right? So the derivative of negative 2x is just negative 2, plus, well, negative 3/5 times 4/5, x to the negative, now this is going to be an 8/5. We subtract 1 whole unit, or 5 over 5, gives us from negative 3/5 to negative 8/5, right there. Now if I multiply this out, simplifying, I have d squared y over dx squared is equal to negative 2 plus negative 3 times 4 is a negative 12. Over 5 times 5 is 25. X to the negative 8/5 power. But we're not done. Okay? Not finished at all. So I'm going to just rewrite this here so we can see it. D squared y over dx squared is equal to negative 2 plus negative 12 over 25. X to the negative 8/5. Okay? From there, I need to find the third derivative. Power rule again still applies. And then what's nice is derivative of -2 is just 0, so 0 here, which we'll eventually eliminate. And then we use the power rule again, -8/5 come out front, -8/5 times and -12/25 times x to the, we subtract the exponent by 1, subtract that in -8/5 by 1, or -5/5, or subtract 5/5. So it'll be -13/5 right there. Okay, let's simplify and clean this up here. d to the third power y over dx to the third is equal to, don't need the 0, -8 times -12, and is a positive 96 over 5 times 25 is 125. And now we have x to the -13/5 power. Okay? Well, I don't like to have a negative exponent in my final answer here, so I'm going to bring that exponent down, or x to the negative exponent, bring it down to the denominator, make it positive. So we have d to the third power y over dx to the third is equal to 96 over 125 x to the positive 13/5 power. And there we have our final answer. Y equals 99x to the 99th power. Okay? And we wanted to find the 100th derivative, d to the 100th power, y over dx to the 100th power. Okay? So let's go think about this for a second. Okay? We're going to take our time with this. Okay? This is obviously not something that you're going to multiply everything out. We're going to try to attack this differently. Okay? So what I like to do is do a few steps here so I can see a pattern going on. So I'm going to take the first derivative. I'm going to write it right here. dy dx. First derivative would be the 99 comes down, so 99 times whatever 99 we had there, x to the 98th power. Okay? And that's our first derivative. So I'm going to put a little 1 here. So it's like 1. Right? First derivative. Second derivative, if I did that second derivative, d to the 2 power y over dx squared. The 98 comes down, so we have 98 times 99 times 99 times x to the 97th power. Okay? Well, we keep doing this to a third one here. Third one. D to the third power y over dx to the third power. 97 comes down times 98 times 99 times 99 times x to the 96th power. Okay? So as I keep taking my derivatives and keep going down more and more, we're going to keep subtracting our exponent by 1 and multiplying it down and then subtracting by 1. Okay? So now let's try to predict what's going to happen when we get down to our, let's say, 100th derivative. What's going to happen on the 100th derivative or the 99th derivative, right? So the first derivative gave us the 99 down here, 98 down there, right? Second derivative, 98 down here, 97 was up there, so we keep subtracting. So every derivative we subtract the exponent by 1, right? So our first derivative is subtracted by 1, second derivative is subtracted by 2, third derivative is subtracted by 3, and so our 99th derivative, we subtract the exponent, whatever it is, right, 4. So we have x to the, 99 divided, or sorry, the 99th derivative, not fourth derivative, the 99th derivative there. We subtract our exponent by 99, so we're going to get a 0 up there, okay? A 0 up there. So if we remember, each derivative, we're subtracting the exponent by 1. So the first derivative, we subtract by 1, get 98. 99 minus 1 is 98. Second derivative, subtract the exponent by 2, 97. By 3, 96. And we added whatever that exponent was previously out in front. So our d to the 99th derivative of dx to the 99th power would equal to 1 times 2 times 3 times ... forever. Not forever. To 98 times 99 times 99. Okay. So that's still a very big number. But x to the 0 power is just 1. So at this point, our derivative is just some constant. It's some massive number, some big number, right? 1 times 2 times 3 times forever, all the way up to 99. Times x to the 0 power, which is just 1. Well, when I take the 100th derivative, d to the 100th power, y over dx to the 100th power, this is just a constant. Since it's just a constant, the 100th derivative there is just going to be 0, right? Because the derivative of a constant, no matter how large it is just 0. F of x is equal to x to the 99th power, and we want to find the 99th derivative. So remember, this isn't f to the 99th power, it's the 99th derivative of our function f. So to solve a problem like this, they're not asking you to show every single derivative. I mean, you can, that's going to take forever. Let's go use some critical thinking right there to think about what's going on, maybe make a pattern to get to our final answer. So let's just find the first derivative. F prime of x, we know is, okay, 99 times x to the 98th power. Okay, second derivative, x to the second power, or second derivative. Well, it's the 98 comes out front, so 98 times 99 times x to the 97th power. Okay, well, let's do a third one, right? F to the third derivative of x is 97 times 98 times 99 times x to the 96th power. So every single derivative, as we go down, we're subtracting the exponent by 1, right? So first derivative, so this is the first derivative, second derivative, third derivative, we subtract the exponent by 1. So we have 98th power, 97th power, 96th power. What would happen if we did the 99th derivative, right? So we went down to the 99th one, f to the 99th power. What would we have? See if we can predict this. Well, the exponents would keep coming down. Our exponent would be x to the, well, we subtract the exponent each time. So first derivative subtract by 1, second derivative subtract by 2, subtract by 3, right? So we're subtracting our exponent by 99. Well, 99 minus 99 is 0. So, and we have every single number leading up to it right there. So the previous exponent would have been 1. So we have 1 times 2 times 3 times up till 97, 98 times 99 times x to the 0 power. Well, x to the 0 power is just 1, right? And 1 times whatever this is just whatever that is. Well, what do we see here? We have 1 times 2 times 3 times 4 times 5 times 6 all the way up to times 97 times 98 times 99. Isn't that the same as 99 factorial? And so we can rewrite our final answer here, f to the 99th power, or 99th power derivative, the 99th derivative of f, to the power, is 99 factorial. And there we have it, some large number, which whatever 99 factorial is, and there's our answer.
Minute Math. When you need help, you use Minute Math. Minute Math. When you need help, you use Minute Math. MinuteMathTutor.com.